The overall goal of this protocol is to demonstrate a rational synthetic approach to helical polycarbodiimides bearing modifiable pendant groups and visualize the secondary structures assembled from them by means of atomic force microscopy.
These studies are of particular interest to develop experimental procedures for the preparation of desirable architectures. These architectures may then be exploited as potential sensors, optical switches, or biomedical applications.
The main advantage of this technique is that it can be easily applied to different polycarbodiimide scaffolds to make specific assemblies, such as donuts, ribbons, fibers, superhelices, spheres, and so on.
The implication of this technique extends towards using helical polycarbodiimide scaffold as a potential drug carriers, because these protein-like macromolecules self-assemble into unique architecture in a controllable fashion.
To begin this procedure, add 1 gram of ET monomer and 0.894 grams of pH monomer to a clean 20 milliliter scintillation vial containing a magnetic stir bar in a glove box. Then, add 0.018 grams of binol catalyst to the scintillation vial. Add approximately 3 to 5 milliliters of anhydrous chloroform and gently stir to dissolve both the monomer and the catalyst. After capping the vial, allow the reaction mixture to stir overnight at 25 degrees Celsius. Redissolve the polymer in 5 to 10 milliliters of chloroform, and reprecipitate it in 250 milliliters of methanol to remove the residual catalyst. Then, dry the precipitate.